10th root of c to the 5k. Do what? That's it. Nothing combines. Times the square root of c to the negative k. Is that right? 1/2 power. Ready? It's not as bad as it looks. Because I mean, you first look at that, you're like, where in the world did I even start? But it's not bad. I would start by rewriting it, because a lot of times going back and forth, it's kind of like logarithms. We're fixing to start talking about logarithms. If you have trouble in this form, change it to fractional exponents. So you've got c to the 5k to the 10th power is c to the, what? 5k over 10. With me? You've got the power over what's your root. Times, let's change this. The stuff inside, we'll do c to the negative k to the 1/2 power raised to the, what? Square root, which is the 1/2 power, right? Stop, take that. It's the square root of this, right? So the square root, how do you take a square root? Like 9, the square root of 9 is the same thing as 9 to the 1/2. So I just took the stuff and I raised to the 1/2 power. Now you just got a lot of rules for exponents. 5k over 10, what can you do there? So it's going to be k over 2. We just reduced that fraction. 5 over 10 is 1/2. Times, what rules do you have here? That's a power to a power, right? That was like x squared to the 3rd power. So c to the negative k over 4. Doesn't that look a whole lot better? Because we just multiply k over 1, multiply all the tops, multiply all the bottoms. Negative k over 4. Now you have like a fraction, like a x squared times x to the 3rd. What do you do with the exponents? You just add them. So we're just going to add those exponents together. But we need common denominators, so k over 2, what do we need on bottom there? Need a 4, so 2k over 4. So add those. C to the k over 4 power. All that's equal to the c to the k over 4. It looks a whole lot better than that, which is the 4th root of c to the k power, if you want to write it like that. Either way. You can only flip it to make a negative exponent into a positive exponent. That's the only time. Okay, last section. Rationalizing denominators. Really, we've already talked about it. We talked about it when we did imaginary numbers. You do it the same way. But I just want to remind you. To rationalize a part of a fraction, make the radicand into a perfect root using multiplication. I'll show you what that means. If there's a binomial, we multiply top and bottom by the conjugate of the root. 5 over the square root of 6. These are easy, guys. Probably do them in your head. 5 over the square root of 6. Rationalizing something, if it says rationalize the denominator, let me explain, now that we know a little bit more about rationals, what that actually means. Is that a rational number? Square root of 6, no. Square root of 6 is irrational. So if I tell you to rationalize the denominator, I'm saying make the denominator something that is a rational number. Easy. Well, all you have to do if you have a square root on the bottom, just multiply by that. Square root of 6, multiply the bottom by the square root of 6. If you do the bottom, do the top as well. So that's going to be 5 root 6 over what? 6. Because square root of 6 is 6. So have we rationalized? Is that a rational number now? 6? Yeah. So we rationalize the denominator is what that's called. Make sense? That's it. If it says rationalize the denominator, make the denominator a rational number, that's all you're doing. What if you got 3 over 2 plus root 5? Not 2 plus. 2 minus. You multiply, if you have a binomial, and when I say binomial, there's 2 terms on the bottom now. Yeah. If you have a binomial on bottom, you multiply by the conjugate. The reason we didn't have to do that there is because we had a single term. We'll just multiply by the square root of 6. So now we've got on top 6, what? On top, 6 minus, good job. And on bottom, they're conjugates. So 4, 2 times 2 is 4. We don't have to worry about inside, outside. Square root of 5 is negative 5. So you have 6 minus 3 root 5 over negative 1. which is what? Negative 6. It's just dividing both by negative 1. Negative 6 plus 3 root 5. So not only did you rationalize the denominator, you completely did away with the denominator there. You actually divided that. Here we go, last problem says rationalize the numerator. We've never rationalized the numerator before, but you do the same thing. Top. So rationalizing the numerator means get all the square roots off the numerator. So we've got square root of x plus h plus 1. That's kind of nasty looking. Square root of x plus h plus 1. Is that right? Minus the square root of x plus 1 all over h. You know what that reminds me of? That reminds me of the difference quotient problems. That f of x plus h minus f of x all over h. That's what this, well, actually that's what this is. To where you've got the square root of x minus 1 would be your f of x. That's what this type of problem is. So we're going to multiply to rationalize our numerator for some reason here. Well, I know why they're doing it. When we start talking about limits, you'll see some of these. To rationalize the numerator, we're going to multiply by the square root of, can y'all do this? X plus h plus 1 plus the square root of x plus 1. Just the conjugate. Yeah, we're rationalizing the numerator here if it does ask you to do that. So on top, this looks ugly, but it's not as bad as it looks. Because when you multiply a square root times a square root, what happens? X plus h plus 1. It just undoes the square roots. That's like the square root of 3 times square root of 3 is 3. Make sense? Now, is there any sense in doing this times this? No, because it's just going to cancel with this times this. They're conjugates. So now all you got to do is negative times a positive would be a negative, put it in parentheses. Square root of x plus 1, square root of x plus 1 is x plus 1. All over h times the square root of x plus h plus 1 plus h times the square root of x plus 1. What's on top? What's left? Just h, right? Over, I shouldn't have folded that, or multiplied that out. Do you see why? Go back and leave it as h times the square root of x plus h plus 1 plus the square root of x plus 1. I should not have done it, because what happens? H's cancel and leaves you with 1 over, good job, square root of x plus h plus 1 over the square root of x plus 1. Any questions? Good.